In this example number 2 is basically the same example we did before, but now we are changing the material to ductile material. In this particular material is ductile material, and you can see that your sigma yield in tensile is 70 KSI, and your ultimate is 90 KSI. So most of the problem is all the problem is basically the same as the previous example. We are keeping all exactly the same. I just want to show you what really happens if I just change the material. If you just go one material to another material. Okay, everything is identically the same. The only thing that's going to change is the material properties. So your first set, this is all going to be the same. Don't forget multiplying this by 1.5. This is all the same as your previous example. These values will be the same. Nothing changes. Even if it's ductile material, remember you need to find this. We are not using this. Now, in this particular example, you have to know that this is steel. So I need to use this. This value is somewhere here in between here. So it will be there. This is 90, right? SUT is 90. So 90 is somewhere there. So you go there and put this value. This value I actually got from the exact equations that I got from your code. They use the exact equation. So this will be QA and QB for bending, and this is QS, and this value is somewhere here, and it will be approximately 0.87. Okay, so the only thing that we are changing from the previous example, this is 0.83, this is 0.87, and you're getting a value of 1.665 and 1.304. Okay, there's nothing that's going to change here because again, has to be loading, not the type of problem you're solving. Here, obviously, what's going to change is this is 665, 1.304. Everything else is the same. So you can expect these values are going to change. Let me tell you the new values that you will get here for your alternate stress. And I get a value of 23.38, 11.20, 11.20. And now, instead of using sigma 1, I could use sigma 1 if I wanted to, but I want to use von Mises, okay? And your code actually gives you your von Mises stress, that's 30.39 KSI, okay? Sorry, alternate. This is given in your code. Now, this particular value, this is going to change again. And your mean value then here becomes, this is 1.665, and this is 1.304, and that's the only thing that changes here. And then these numbers will change and the values will change. So the new values are 19.88, 11.20, 11.20, and you're going to find your principal stresses. Your principal stresses, mean principal stresses are the following. And we really want, for the traditional approach, is just to use the von Mises stress that your code also gives you, KSI. And then, so these are the values that we'll be using here. This is 27.78. And then this was 30.39, 30.39, 27.78. This is 70. That's what changes in this problem. But all I did was just change the material property. Okay, and then this gives you a value of 43.95. This is the Goodman stress. And by the way, this stress, Goodman stress, right? The value that I get here, this is the equivalent fully reversed stress. Okay, so that's the stress value that we actually doing. You can see this value that's here, so it will be equal to where your mean is equal to 0. If your mean is 0, it's fully reversed. Okay, so in this particular problem, we are just give me 1 second. You want to have this, but this is going to come from your plots. And then same thing here. I want to find SE. Now for your material, remember S is 90, and for iron, not for iron, for steels now, we are using steels. This number is going to change. It will be different. So therefore, this number will be different. Okay, and therefore, this number will be different. Okay, so I would just rerun the MATLAB code and see what we get for those values. Then again, this number will be different and this number will be different. And then, so when I run the whole MATLAB code, this is what I'm really getting. Just give me a second. So you can see the MATLAB code when I run it. The value of SE is here. You see the value of SE in the next plot, in the SN. So your MATLAB code actually runs all the different cases, and your SE has a value of 22.23, and your equivalent stress of 43.95. And this is the traditional value that we want to use. And you can see this value will be 178 N. So 178, if you look what we had before, we had, by changing the material property, this is 178,000 now, 260. And look what we get then by actually solving the problem. Just give me a second. So now I'm getting 43 days. So you can see that by changing the material, I increased my basically I multiplied by 2.5. So that's how we actually solve this problem.